Hi students, welcome to our physics class. In this class, I am going to explain the topic electricity. The subtopic is EMF, electromotive force. What is electromotive force? Electromotive force of cell. As per definition, potential difference between the terminals of the cell when it is open circuit means the potential difference between the terminals when it is not connected to the circuit. Without connection, any circuit is not connected to the cell, then potential difference between the terminal inside the cell is called EMF of the cell. EMF of the cell, that is nothing but energy the cell can provide to move the charge one place to another place. Electromotive force, energy supplied to the electrons motivate to move one place to another place. Electromotive force given by cell. In simple way, we can say that is potential difference. We know already in last class we learned about potential difference. What is potential difference? Work done to carry unit charge across the conductor. Here work done is nothing but energy providing to carry the charge one place to another place in the conductor, in the circuit. That is done by cell. That is called electromotive force of cell. EMF of cell. How the cell works, we learn here. Take one glass jar, take some chemical acid, H2SO4 acid. This acid is called electrolyte. It works like a conductor, electrolyte. So take some acid in the jar. Take two terminals in the jar. When we place two terminals in the jar, immediately due to chemical reaction inside the solution, inside the acid, what will happen? The electrolyte decompose into positive and negative ions. The electrolyte is here H2SO4, sulfuric acid. When we place it two terminals inside the electrolyte, immediately electrolyte decompose because of chemical reaction. Electrolytes decompose into two types of ions, positive ions and negative ions. Now whenever the electrolyte decompose two types of ions, positive ions and negative ions, the positive ions accumulate on one terminal. Here one terminal is copper terminal, and negative ions accumulate on another terminal, that is another terminal is zinc. Why we are taking different terminals, copper terminal and zinc terminal? We are taking two terminals different. Why? If both are same ions, different ions cannot accumulate in different terminals. So that is why different ions, different terminals I have taken. Here copper, here zinc terminal. Whenever electrolyte is decomposed into two ions, positive ions and negative ions, all positive ions in the electrolyte accumulate on the copper plate, and this copper plate gain positive terminal, that is anode. The copper plate become positive terminal called as anode. Now immediately the negative particles, here see positive particles are H plus positive particles, negative particles are SO4 negative particles. These SO4 H plus ions, here see positive ions and negative ions decompose. Positive ions accumulate on copper and negative ions, SO4 negative ions accumulate on zinc plate. Then this zinc plate gain negative charge. So it's called cathode. Now anode and cathode. Yes, now we are connecting one circuit to anode and cathode. What will happen? When we connect a circuit to the terminals or electrodes. Now we can say them as electrodes. When circuit is connected to the electrodes, what will happen? These electrons, negative particles moves along the circuit towards the positive terminal. Attraction. Positive terminal attract all electrons. So here electrons move along the circuit towards the positive terminal. Now positive particles move along the terminals towards the negative terminal, cathode. So such a way the transfer of electrons taken place in the circuit because of attraction by this anode, because of attraction by this cathode. Positive particles moves towards the zinc plate. Negative particles nothing but electrons moves towards the copper plate, towards the anode. So such a way the charge carries in the circuit. Then when the charges carries through the circuit, the bulb will glow. We can connect bulb to this in the middle of the terminal, middle of the circuit. Here bulb glows when it is connected to the terminal. See, this is structure of cell. So this is the working of circuit. Now here what will happen? All electrons accumulate again, come attracted by the anode now. Then again transfer to this electrolyte to zinc. And positive particles comes to zinc. And again it attracts electrons. Again continuous process. However, it is happening here same in the electrolyte also. Because of attraction and repulsive force, it again works in the transfer of electrons taken place in the electrolyte. So then again receives electrons received by this terminal. Again transfer through the circuit. This is continuous process. This can do by the cell until total voltage drop. What is voltage drop? Here the electrolyte cannot decompose when the power of the electrolyte is completed. The power of the electrolyte decreases. Then electrolyte cannot decompose ions. Then whenever cannot decompose ions, these electrons transfer in the circuit will not take place. So that means what? The power of the cell decreases. If you observe here, terminal voltage nothing but voltage in the circuit which is connected to the cell. This is circuit voltage in this circuit connected to cell, that we take as V. We know voltage in the terminal, voltage in the circuit represented by capital V. Capital V is taken as work done to carry charge. Voltage potential difference. Voltage nothing but work done to carry charge. So this is, if you take W dash or W dash by Q. If W dash is nothing but the voltage, the work done to carry charge inside the circuit, circuit that is connected to the cell. So in this circuit, work done to carry charge, W dash by Q, capital V. So this is voltage in this outside circuit. Now voltage drop. Where will take in place voltage drop? Inside the cell. So just now I said continuously using the potential difference. So the potential difference for what? To carry charge, work done to carry charge, energy utilized for carry charge inside the circuit, inside the electrolyte, inside the acid is called voltage drop. When it is energy is spending, so what will happen? Gradually the bulb glows, until bulb glows, the energy is consuming. So by that this power will decrease. That is called voltage drop. The voltage drop we can take as small v, represented by small v. So work done to carry charge inside the cell. Inside the cell. Here small w and charge q. Charge is q, same. But here work done outside in the circuit. Here work done inside the battery. Inside the battery. So total potential difference, total circuit, in the total circuit, total connection. What is the total potential difference? Is called epsilon, EMF. That is only EMF. EMF, electromotive force in the total circuit. Here what? Cell plus outside circuit, cell and circuit, total. In the total connection, total circuit, EMF, electromotive force in the total circuit is taken as potential difference outside and potential drop inside. Add these two, then we get EMF. The symbol of EMF is epsilon, small e, epsilon. Small e is equal to potential difference in the outside circuit and potential difference in the, that is nothing but potential drop inside the battery, inside the cell. So add these two, total EMF you will get. Total potential difference or total electromotive force along the total circuit, EMF denoted by epsilon. Here capital V plus small v. This is the formula for total electromotive force. Total electromotive force in the total circuit is EM, that potential difference in the outside circuit and potential drop is in the inside cell. Both you have to consider. Both add. That gives total electromotive force of the circuit. Capital V plus small v. From this we can adjust. If you want capital V, that means outside terminal potential difference you can find out. V is equal to, if you know E minus total EMF minus inside potential drop inside the battery, small v. This is capital V is equal to E minus small v. So just changing the subject. V is equal to E minus small v. If you want to voltage drop inside the battery, small v, inside the battery, small v is equal to same epsilon minus v is equal to epsilon minus potential difference outside the circuit. So such a way we can find out potential difference of whole circuit. Nothing but EMF, electromotive force, to carry the charge along the total circuit. You can find out epsilon, or we can find out potential difference only in the circuit, or we can find out potential difference in the battery. That means inside the cell. That also you can say as potential drop. Potential drop. Now finally formula is epsilon is equal to potential difference outside circuit and inside battery, inside cell. So from this you can find out EMF outside and inside of the cell and total EMF of the total circuit. That's all for now. Thank you for watching.